Picture this: the deep, valorous night sky stretching endlessly above you, untouched by city lights or modern distractions. Thousands of years ago, this same sky captivated the minds of ancient civilizations, who gazed upward with nothing but their eyes and an unshakable wonder. Without telescopes or satellites, they mapped constellations, predicted eclipses, and built monumental structures that aligned perfectly with the movements of the sun, moon, and stars. How did they achieve such precision? What secrets did they uncover about the cosmos that still leave us in awe today? This is the story of humanity's first astronomers, the visionaries who turned the heavens into their classroom and left behind a legacy etched in stone and myth. From the towering pyramids of Egypt to the mysterious stone circles of Stonehenge, these ancient cultures didn't just observe the sky, they wove it into the very fabric of their lives. The Babylonians recorded planetary movements on clay tablets with astonishing detail. The Mayans crafted calendars so accurate they rival our modern calculations. And the Egyptians aligned their grandest monuments with celestial events, as if speaking directly to the gods above. These weren't just random acts of curiosity. They were deliberate, sophisticated attempts to understand the universe. Their achievements force us to ask, what did they know that we've only rediscovered centuries later? This journey into the past isn't just about stargazing. It's about uncovering the roots of human ingenuity. Long before telescopes or space probes, our ancestors decoded the cosmos with nothing but patience, creativity, and an unrelenting desire to make sense of the world above them. Their stories are written in the alignment of temples, the precision of ancient calendars, and the myths that have been passed down through generations. As we explore these ancient eyes on the cosmos, you'll discover how their celestial wisdom shaped civilizations, guided explorers, and even laid the groundwork for the science we rely on today. So let's step back in time and see the universe through their eyes, because the sky they studied is the same one that still inspires us tonight. The night sky was humanity's first clock, calendar, and compass, a silent guide woven into the rhythms of daily life. Imagine standing on a windswept plain 30,000 years ago, tracing the arc of the sun as it shifted with the seasons. Early humans didn't just notice these patterns, they etched them into cave walls like the famous Lascaux paintings in France, where clusters of dots may mirror the Pleiades star cluster. These weren't idle doodles but careful records, a way to mark the passage of time and predict the return of migrating herds or the ripening of wild grains. Even the simplest tools, a stick planted in the earth to cast a shadow, became instruments of discovery, revealing the sun's path with startling accuracy. For these ancient watchers, the cosmos was inseparable from survival. The rising of certain stars signaled the floods of the Nile, vital for Egyptian agriculture. In Mesopotamia, the appearance of Sirius just before dawn marked the brutal heat of summer, a warning to store water and prepare. Every culture had its own celestial shorthand, passed down through generations like a sacred language. The builders of Stonehenge aligned massive stones to catch the first light of the winter solstice, while the ancestral Puebloans of Choco Canyon carved spiral petroglyphs that channeled sunlight into precise daggers of light during equinoxes. These weren't just feats of engineering, they were acts of reverence, a dialogue between earth and sky. What's truly remarkable is how these early observations blossomed into precise knowledge without the aid of written language or complex tools. Take the Nebra sky disk, a bronze artifact from Germany dating back to 1600 BCE. Its gold inlays map the Sun, Moon, and Pleiades with uncanny precision, suggesting an understanding of lunar cycles that would take modern astronomers millennia to rediscover. Or consider the Aboriginal Australians, whose oral traditions preserved detailed star maps for over 65,000 years, guiding travelers across vast deserts. These weren't primitive guesses, they were the seeds of astronomy planted long before the first cities rose. The deeper we dig into these ancient practices, the clearer it becomes. Their connection to the cosmos was as practical as it was profound. When a Babylonian priest tracked Venus's wanderings, he wasn't just charting a planet, he was divining the will of the gods. When a Polynesian navigator read the stars to cross thousands of miles of open ocean, he wasn't just following lights in the sky, he was trusting a celestial roadmap honed over centuries. This interplay of myth and measurement, of ritual and observation, reveals something timeless about humanity. We've always looked up not just to predict the future, but to find our place in something vast and mysterious. And in that shared wonder across thousands of years and countless cultures, we're still more alike than different. The ancient Egyptians didn't just build monuments, they engineered celestial timepieces in stone. Take the Great Pyramid of Giza. Its sides aligned with the cardinal directions so precisely that even modern tools struggle to find a fraction of a degree's error. How did they achieve such accuracy without compasses or satellites? Scholars believe they used the stars, tracking the circular motion of circumpolar constellations like the Big Dipper around the North Celestial Pole. But their brilliance didn't stop there. Venture south to the Temple of Karnak, where the axis of the sacred precinct aligns perfectly with the winter solstice sunrise. On that shortest day of the year, sunlight would pierce the temple's innermost sanctuary, illuminating statues of the gods as if renewing their divine power. This wasn't just architecture, it was astronomy set in sandstone. At the heart of Egyptian sky watching was Sirius, the brightest star in the night sky. Its annual rising just before dawn in mid-July coincided with the Nile's life-giving floods, an event so vital it marked their new year. Priests observed this heliacal rising from temple rooftops, announcing the coming of fertile silt and abundance. They called Sirius Sopdet, linking it to the goddess Isis, whose tears were said to swell the river. This fusion of myth and observation reveals how deeply astronomy was tied to both survival and spirituality. The Egyptians didn't separate science from the sacred. Their celestial knowledge was a dialogue with the gods. One of their most stunning legacies is the Dendera zodiac, a bas-relief carved onto a temple ceiling around 50 BC. This intricate map of the heavens blends Egyptian constellations with Babylonian astrology, showing Taurus as a bull god and Aquarius as the flood-bringer Hapi. But what's truly astonishing is their understanding of precession, the slow wobble of Earth's axis that shifts the stars over millennia. The zodiac symbols suggest they recognized this phenomenon centuries before Hipparchus documented it in ancient Greece. Their star charts, painted on coffin lids to guide souls to the afterlife, weren't mere decorations. They were precise navigational tools for both this world and the next. Even their mythology reflected cosmic order. The god Osiris, ruler of the underworld, was linked to the constellation Orion, while his sister wife Isis shone as Sirius. Their son Horus, the falcon-headed sky god, embodied the sun's daily journey. This celestial family mirrored the rhythms of the Nile and the seasons, reinforcing a worldview where heaven and earth were inseparable. When pharaohs built their tombs along the west bank of the Nile, where the sun died each evening, they weren't just picking a scenic spot. They were replicating the sun god Ra's nightly voyage through the underworld, ensuring their own rebirth among the stars. The genius of Egyptian astronomy lies in its harmony. They didn't compartmentalize. A single obelisk could serve as a sundial, a symbol of the sun's rays, and a conduit for divine energy. Their calendars split into lunar months and solar years, balanced administrative needs with agricultural cycles. And while their tools were simple shadow clocks, Merc hits for aligning foundations, their vision was vast. They saw time not as linear but as a great spiral where celestial events repeated in cycles, weaving the eternal into the everyday. That's why their legacy endures. They didn't just watch the sky. They listened to it, decoded its rhythms, and built a civilization in its image. While the Egyptians aligned pyramids with the stars, the Babylonians turned the sky into a mathematical playground. Their clay tablets, etched with wedge-shaped cuneiform, reveal the birth of systematic astronomy, not as poetry or myth, but as precise calculations. Picture scribes in the ziggurat shadows, recording Venus's position night after night for decades, spotting patterns we'd now call orbital cycles. They didn't just observe, they quantified, creating the earliest known trigonometric tables to predict celestial events down to the hour. One tablet from 300 BC even details Jupiter's motion using geometric principles we'd later credit to medieval European scholars. What set the Babylonians apart was their obsession with data. The Enuma Anu Enlil, a sprawling collection of 70 tablets, wasn't just an astronomical log, it was a cosmic instruction manual. When Mars lingered too long in Taurus, it signaled war. A halo around the moon foretold famine. Kings consulted these omens before launching battles or planting crops, blending science with statecraft in ways that shaped empires. But beneath the mysticism lay rigorous methodology. By tracking lunar eclipses in 18-year cycles, now called the Saros cycle, they could forecast celestial shadows centuries before telescopes existed. Their predictions were so reliable that modern astronomers still reference their records to study ancient eclipses, their most enduring invention, the zodiac. Dividing the ecliptic into 12 equal slices, each named for constellations, gave humanity a shared language for the sky. This wasn't just astrology, it was a coordinate system, a way to map planetary movements with mathematical precision. The Greeks would later adopt it, the Romans would popularize it, but its roots lie in Babylonian clay. Even our 60-minute hour stems from their base 60 number system, a testament to how deeply their celestial math seeped into daily life. Perhaps their greatest genius was seeing the cosmos as a clockwork machine. While others worshipped celestial bodies as gods, the Babylonians treated them like gears in a grand mechanism, predictable, measurable, and decipherable. A tablet now known as the Babylonian Star Catalogue doesn't just list stars, it assigns them numerical values for brightness, foreshadowing modern magnitude scales by millennia. Their lunar calendars, adjusted with leap months to sync with solar years, became the blueprint for Jewish and Islamic timekeeping. The real marvel isn't just their accuracy, but their mindset. Without lenses or satellites, they grasped a profound truth. The universe runs on rules. When a scribe noted Jupiter's retrograde motion in 400 BC, he wasn't seeing a capricious god changing direction. He was tracking a puzzle to be solved. That shift from myth to mathematics marks the true dawn of astronomy, and in the cracked clay of their tablets, we find the first sparks of a revolution, one that would eventually carry us to the stars. High in the jungles of Central America, the Maya turned the cosmos into a living calendar, their temples and codices revealing a sky-watching tradition so precise it rivals our modern calculations. At El Caracol, an observatory in Chichen Itza, narrow slits in the circular tower frame Venus at its most extreme positions in the sky, proof that Mayan astronomers tracked the planet's complex dance with mathematical brilliance. They didn't just note its appearances, they predicted its movements across 584-day cycles, an achievement requiring generations of meticulous record-keeping. To the Maya, Venus wasn't merely a celestial body, it was Kukulkan, the feathered serpent god whose return dictated the timing of wars, coronations, and sacred offerings. The Dresden Codex, a bark paper book surviving centuries of humidity and conquest, holds the key to their genius. Its pages feature Venus tables so accurate they account for the planet's irregular orbit, correcting calculations by a mere 2 hours over 500 years. Another section predicts solar eclipses using multiples of their sacred 20-day months, a system so reliable it could forecast celestial events centuries into the future. These weren't abstract equations, they were survival tools. When Venus rose as the morning star, it signaled the start of planting season. A lunar eclipse might postpone a battle, lest the gods withdraw their favor. Every celestial event was a conversation with the divine, written in numbers and stone. Their long count calendar, spanning over 5,000 years, reveals an even grander vision of time. Unlike our linear calendars, the Maya saw time as layered cycles, nested wheels of days, months, and epochs rotating in harmony. The much-debated end date of December 21, 2012, wasn't a prophecy of doom but the completion of one great cycle and the birth of another, like a cosmic odyssometer resetting. Modern panic over this apocalypse overshadowed the real marvel. A civilization that, without telescopes, calculated the solar year as 365.242 days closer to today's measurement than the Gregorian calendar's 365.2425. What's most striking is how they wove astronomy into every facet of life. The pyramid at El Castillo casts a shadowy serpent slithering down its steps during equinoxes, merging architecture with celestial theater. Their numbering system, using bars and dots with a shell symbol for zero, enabled calculations light years ahead of their contemporaries. Even their myths reflected cosmic order. The hero twins of the Popol Vuh journeyed through the underworld like Venus vanishing and reappearing, a metaphor for death and rebirth written in the stars. The Maya remind us that astronomy was never just about observation, it was about meaning. Their priests didn't merely track planets, they decoded divine will. Their farmers didn't just follow seasons, they danced to a celestial rhythm. In their world, the sky was a book, and they were its most devoted readers, leaving behind a legacy where science and spirit orbited as one. Standing silent on England's Salisbury Plain, Stonehenge's towering monoliths have whispered secrets to the wind for over 4,000 years. At dawn on the summer solstice, the sun's first rays slice precisely between the heel stone and slaughter stone, flooding the central altar with golden light. This isn't random chance, it's celestial engineering on a scale that staggers modern minds. The builders hauled bluestones from mountains 150 miles away, each weighing up to 4 tons without wheels or draft animals. Why expend such effort? Because to Neolithic peoples, the sky wasn't just a spectacle, it was a sacred clock, and Stonehenge may have been its most intricate hand. Recent laser surveys reveal clues etched in the stones themselves. 73 of the original 82 sarsen stones bore carvings of daggers and axes, symbols found in contemporary astronomical artifacts across Europe. Even more compelling are the 56 Aubrey holes encircling the monument. These chalk-filled pits align with lunar standstills, the moon's most extreme positions in its 18.6-year cycle. Archaeoastronomers suggest wooden posts in these holes could have been moved like counting beads to predict eclipses, turning Stonehenge into a colossal calculating machine. Imagine moonlight glinting off these markers as priests traced celestial patterns in the earth, forecasting cosmic events with nothing but memory and mathematics. But Stonehenge wasn't alone in this cosmic conversation. 30 miles northeast lies the Durrington Walls settlement, where pig bones show mass feasting at midwinter, the solstice counterpart to Stonehenge's summer alignment. Pathways between the sites mirror the Milky Way's path, suggesting a ritual journey mirroring the soul's celestial voyage. Even the nearby Cursus earthworks, predating Stonehenge by centuries, align with sunrise on equinoxes. This wasn't a single monument but a sprawling celestial observatory, where every mound and post hole whispered of the sky's rhythms. The true genius of Stonehenge lies in its adaptability. Over 1,500 years, its purpose evolved from a cremation cemetery to a solar temple to possibly a lunar calculator. The blue stones, initially arranged in a double circle, were later rearranged to form the iconic horseshoe of trilithons. Each modification refined its celestial precision, like generations of scholars updating an astronomical textbook. Modern experiments show that the trapezoidal gaps between upright stones create acoustic shadows that amplify specific sound frequencies during solstice alignments. Was Stonehenge not just an observatory but a concert hall for the cosmos, where chants resonated with planetary harmonies? What's often overlooked is the human cost of this cosmic ambition. Analysis of bones from nearby graves reveals survivors of prehistoric brain surgery, possibly astronomer priests, who endured trepanation to open the mind to celestial visions. Others show signs of rickets from lifelong night watches. These weren't passive stargazers, they were pioneers who reshaped their bodies and landscape to commune with the heavens. Their legacy challenges our assumptions about primitive societies. Without writing or metal tools, they achieved celestial precision that would take later civilizations millennia to rediscover. Stonehenge stands not just as a monument to the sky, but to the indomitable human urge to decode the universe, one solstice sunrise at a time. The Greeks didn't just watch the stars, they tore open the ceiling of mythology and let mathematics flood in. Where earlier civilizations saw gods driving chariots across the sky, thinkers like Thales of Miletus spotted patterns obeying natural laws. By 600 BCE, he'd predicted a solar eclipse not as an omen, but as a calculable event, shocking his contemporaries. This shift from storytelling to systematic inquiry marks one of humanity's greatest intellectual leaps. The Ionians pioneered this revolution, proposing Earth floated in space rather than resting on some cosmic turtle, an idea so radical it would take 2,000 years to become common knowledge. Enter Aristarchus of Samos in the 3rd century BC, the first to suggest the unthinkable that Earth orbits the Sun, not the other way around. His calculations, though crude by modern standards, estimated the Sun's distance at 20 times the Moon's, a figure wildly underestimated but conceptually groundbreaking. He argued the stars must be unimaginably distant since they showed no parallax shift as Earth moved, a stroke of insight that placed the cosmos on an entirely new scale. Had his heliocentric model gained traction, astronomy might have advanced centuries faster. But in a world where Aristotle's geocentric views dominated, his ideas were shelved like forbidden scrolls, waiting for Copernicus to rediscover them. Meanwhile, Hipparchus was quietly revolutionizing celestial cartography from his observatory on Rhodes. His star catalogue, completed around 130 BCE, mapped over 850 stars with such precision that modern astronomers still reference it to study stellar motions. He discovered precession Earth's slow wobble that shifts the stars over 26,000 years by comparing his measurements to Babylonian records centuries older. This meticulous cross-cultural verification reveals a scientific mindset we'd recognize today. His magnitude system classifying stars by brightness remains the foundation of how we measure celestial luminosity now. The crown jewel of Greek astronomical ingenuity, the Antikythera Mechanism, salvaged from a shipwreck in 1901. This bronze marvel, dating to around 100 BC, contained over 30 meshing gears that modeled planetary motions with astonishing accuracy. Recent CT scans reveal it could predict eclipses decades in advance, track the 4-year Olympic cycle, and even account for the Moon's elliptical orbit, a feature we'd attribute to Kepler in the 17th century. Its differential gearing, previously thought invented in the 16th century, proves the Greeks had mechanical computing skills lost to Europe for millennia. This wasn't just a tool, it was a portable cosmos, turning celestial mechanics into something you could hold in your hands. Ptolemy's 2nd century Almagest, though flawed by today's standards, became astronomy's Bible for 1400 years. His complex system of epicycles, circles upon circles, explained planetary retrograde motion well enough to guide navigators and calendar makers until the Renaissance. What's often overlooked is his rigorous methodology, detailed observational records, error estimates, and geometric proofs that set a template for scientific inquiry. Even his mistakes were instructive, showing how brilliant minds can be trapped by the paradigms of their time. The Greek legacy isn't just about individual discoveries, it's about how they thought. Anaximander imagined infinite worlds in space. Empedocles proposed light takes time to travel. The atomists speculated other planets might harbor life. These weren't random guesses but hypotheses grounded in observation and logic. Their debates in the Lyceum and Academy birthed the scientific method itself, where argument required evidence and authority bowed to reason. When Eratosthenes measured Earth's circumference to within 1% accuracy using nothing but shadows and geometry, he proved the power of this new approach. The Greeks taught us the universe isn't just to be worshipped or feared, it's to be understood. And in that understanding, they handed us the keys to the cosmos. In ancient China, the night sky wasn't just a canvas of stars, it was an imperial bulletin board, where celestial events carried urgent messages for the emperor himself. The Astronomical Bureau, established as early as the Han Dynasty around 100 BCE, wasn't staffed by stargazers but by scholar officials who held life or death influence. A single misread comet could cost them their heads, while a timely prediction of an eclipse might secure royal favor. Their records, etched onto oracle bones and silk scrolls, note the guest star of 1054, a supernova so bright it outshone Venus for 23 days and left behind the Crab Nebula we study today. These weren't casual observations, they were state secrets, locked in vaults to prevent public panic over heavenly warnings. The Dunhuang Star Atlas, painted on paper around 700 CE, survives as one of humanity's oldest complete star maps. Unlike Western constellations depicting myths, its 1,300 stars form precise bureaucratic grids, mirroring China's imperial provinces. Mars becomes the fire star, its erratic motions signaling potential rebellions. Orion's belt transforms into the Three Ministers, whose alignment predicted harvests or droughts. Every flicker in the heavens had earthly consequences, and astronomers wielded double-edged power. Their accurate forecasts could stabilize empires, while errors might spark dynastic collapses. When a broom star, their term for comets, appeared in 44 BCE, records show it preceded the downfall of Chancellor Zhai Fangjin, forced to commit suicide for failing to interpret its dire meaning. Their tools were as ingenious as their theories. Zhang Heng's seismoscope in 132 CE could detect distant earthquakes, but his armillary sphere, a nested ring device tracking celestial coordinates, revolutionized global astronomy. By the Tang Dynasty, astronomers had refined it to plot planetary movements with error margins under 1 degree, surpassing medieval European models. The Song dynasty's water-powered astronomical clock tower, built by Su Song in 1092, didn't just tell time, it mechanically displayed star positions and eclipses in real time, a feat unmatched until Renaissance Europe. These weren't isolated inventions but parts of an unbroken observational tradition spanning millennia, where each generation calibrated instruments using data from predecessors' star logs. What set Chinese astronomy apart was its fusion of precision and philosophy. The mandate of heaven doctrine tied cosmic events directly to imperial legitimacy. A solar eclipse meant the emperor lost divine favor, prompting rituals where he'd fast and confess faults while astronomers beat drums to scare away the celestial dragon devouring the sun. The meticulousness of their records, like sunspot observations from 28 BCE, ignored by Europe until Galileo reveals a culture that saw no divide between science and statecraft. Even their zodiac, with 12 earthly branches and celestial stems, wove timekeeping into governance, assigning each year cosmic attributes that guided everything from tax policies to military campaigns. The legacy of China's imperial astronomers endures in unexpected ways. Their supernova records help modern astrophysicists study stellar life cycles. Their comet trajectories, logged since 613 BCE, still inform orbital calculations today. But perhaps their greatest contribution was proving that astronomy could be both mathematically rigorous and profoundly human, a discipline where the stars didn't just inspire wonder, but shaped the fate of nations. In a world where we've split science from spirituality, their vision reminds us that the cosmos has always been more than equations. It's a mirror reflecting our deepest questions about power, purpose, and our place in the universe. Buried beneath the sands of modern Pakistan and India, the Indus Valley civilization holds some of history's most tantalizing astronomical secrets. While their script still defies translation, the ruins of cities like Mohenjo-Daro and Harappa whisper of a people deeply attuned to the cosmos. Take the so-called fire altars. At Kalibangan, 7 rectangular platforms arranged in a pattern mirroring the Pleiades star cluster. Archaeologists found these altars aligned with the winter solstice sunrise, suggesting rituals timed to celestial events. Even more striking, the city's streets follow a grid pattern oriented to cardinal directions, a feat requiring precise solar observations centuries before compasses existed. How did they achieve such accuracy? The answer might lie in their water reservoirs, not just for storage, but as reflective pools for stargazing, turning still waters into primitive observatories. The Great Bath of Mohenjo-Daro offers another clue. This massive, brick-lined pool aligns north-south with an error margin of less than 1 degree, rivaling the precision of Egyptian pyramids. Some scholars propose its steps served as a giant sundial, with shadows marking seasonal changes crucial for agriculture in the unpredictable Indus floodplains. Nearby, terracotta tablets depict what might be the earliest known zodiac symbols, a bull resembling Taurus and a horned figure echoing later Hindu depictions of the moon god Chandra. These artifacts hint at a celestial vocabulary passed down through millennia, surviving even as the civilization itself faded into obscurity. What truly sets the Indus Valley apart is their integration of astronomy into daily life. Unlike the grand monuments of Egypt or Mesopotamia, their cosmic knowledge was woven into urban design. Houses had windows positioned to catch equinox sunlight, while drainage systems doubled as alignment markers for lunar standstills. A seal discovered at Harappa shows a figure surrounded by animals, possibly a proto-version of the Hindu god Shiva as Nataraja, the cosmic dancer whose movements symbolize the universe's rhythms. This blending of practical observation and spiritual symbolism would later flourish in Vedic astronomy, where constellations became deities and planetary positions dictated everything from marriage dates to harvest times. The tragedy of the Indus Valley is how much we've lost. When their cities declined around 1900 BCE, whether from climate change or invasion, their astronomical traditions likely scattered with migrating populations. Yet fragments endure. The Vedas, composed centuries later, speak of nakshatra's lunar mansions matching star clusters the Indus people may have tracked. Even today, Punjabi farmers plant crops according to a traditional calendar that suspiciously mirrors solstice alignments found at Indus sites. Their legacy reminds us that astronomical knowledge isn't always preserved in grand monuments or written treatises. Sometimes it lives on in the tilt of a roof, the turn of a season, or the stories we tell about the stars. Perhaps the most poignant evidence comes from a child's toy, a clay cart unearthed at Lothal, a coastal Indus city. Its wheels aren't just round, they're spoked, mirroring the sun wheel symbols found across ancient Eurasia. In this simple plaything, we glimpse a civilization that didn't just observe the heavens, but brought them down to earth, finding cosmic patterns in the humblest objects. While we may never fully crack their celestial code, their ruins stand as silent testimony to humanity's timeless urge to map the skies not with telescopes, but with the world itself. Picture a vast ocean stretching endlessly in every direction. No landmarks, no compass, just the rhythmic swell of waves beneath your canoe. This was the daily reality for Polynesian navigators, who crossed thousands of miles of open Pacific using nothing but the stars, the wind, and their own finely honed instincts. While other cultures built monuments to the sky, these voyagers treated the heavens as a living map, memorizing the rising and setting points of over 200 stars to guide their double-hulled canoes from Tahiti to Hawaii, or New Zealand to Easter Island. Their star compass, known as the Hawaiian Ho or the Carolinian Etak, divided the horizon into 32 directional houses, each anchored by a specific celestial body. When clouds obscured the stars, they read the ocean itself, the angle of swells, the flight patterns of seabirds, even the color and taste of the water, to stay on course for weeks at a time. The brilliance of Polynesian navigation lay in its multi-sensory approach. Stars like Hoculaire Arcturus and Hicyonalia Spica served as celestial signposts, but wayfinders also tuned into subtler clues. A sudden shift in wave patterns might signal an unseen island over the horizon, its presence disrupting the ocean's rhythm long before land came into view. Certain fish species or cloud formations acted as natural buoys, marking the proximity of reefs or atolls. Even the phosphorescence of plankton could indicate currents invisible to the naked eye. This wasn't just navigation, it was a dialogue with nature where every ripple and breeze carried meaning. Maori myths encode this knowledge in stories still told today. The demigod Maui, for instance, didn't just fish up islands, he calibrated his hooks by the Pleiades, ensuring his canoe stayed aligned with celestial markers. The constellation Te Ikaroa, the Milky Way, was envisioned as a great canoe sailing across the sky, its prow pointed toward the future. These weren't mere fables, they were mnemonic devices, preserving vital navigational data across generations without written records. When European explorers marveled at finding remote islands already inhabited, they were witnessing the fruits of an unbroken oral tradition that had turned the Pacific into a Polynesian highway. What's truly astonishing is how modern science has validated these ancient techniques. In 1976, the Hoculaire, a replica Polynesian voyaging canoe, sailed from Hawaii to Tahiti using only traditional wayfinding methods, proving the system's accuracy beyond doubt. Satellite studies now confirm that wave patterns do indeed bend around islands exactly as navigators described. Even the Sea of Darkness, feared by medieval Europeans, the doldrums near the equator where stars vanish during certain seasons, was successfully traversed by Polynesians using zenith stars that passed directly overhead, a technique Western astronomy wouldn't document for centuries. Today, this ancestral knowledge is experiencing a renaissance. Schools like Hawaii's Ohana Wa teach star compass techniques alongside GPS navigation, blending millennia-old wisdom with modern tools. Young navigators learn to feel the ocean's pulse through their feet, sensing currents through the hull's vibrations, a skill that once guided their ancestors to islands smaller than a pixel on Google Maps. This revival isn't just about preserving the past. It's a reminder that sometimes the most advanced technology isn't found in microchips, but in the human mind's ability to see the universe reflected in a wave, a bird's flight, or the steady arc of a star rising from the sea. The Polynesians didn't just conquer the Pacific, they conversed with it, turning the cosmos into a compass that still points the way home. High in the arid mesas of the American Southwest, the Anasazi etched celestial knowledge into stone with breathtaking precision. At Choco Canyon, a spiral petroglyph carved into a cliff face transforms into a dagger of sunlight during the summer solstice. A beam so exact it bisects the carving's center, marking the year's longest day. But this wasn't just a solar calendar, it was a sacred interface between Earth and sky. The same site captures the lunar standstill cycle, with moonlight striking smaller spirals only once every 18.6 years. These alignments weren't isolated, they connected a network of great houses spanning hundreds of miles. Their doorways and roads aligned to celestial events like a massive, landscape-sized observatory. The Pueblo Bonito's east-facing wall catches the equinox sunrise, while nearby Wijiji's back wall frames the winter solstice sunset. Every stone whispered of a cosmos intimately tied to the rhythms of planting, harvest, and ceremony. For the Pawnee people of the Great Plains, the stars were more than guides, they were ancestors. Their Council of Chiefs constellation, what we call Corona Borealis, represented a celestial gathering of tribal leaders, each star an elder holding council in the sky. The Milky Way became the path of souls, where spirits traveled after death, mirrored by earthly rivers flowing toward the horizon. Their earth lodges, built with sacred geometry, aligned so the morning star Venus would shine through the eastern entrance during ceremonies. Skiddy Pawnee priests kept meticulous star charts on buffalo hides, using them to predict the sacred morning star sacrifice, a ritual timed to Venus's appearance as a harbinger of renewal. Unlike Western astronomers who separated observation from meaning, the Pawnee saw no division. When they tracked the movement of the Pleiades to time their corn planting, they weren't just following a seasonal marker. They were heeding the advice of the star women who first brought crops to humanity. Lakota Elder Black Elk's vision of the sky as the hoop of the world reveals a cosmology where celestial and terrestrial realms were inseparable. The Black Hills, their sacred heartland, mirrored the constellation Witchhapi Oangilla, the Big Dipper, with each peak corresponding to a star. Their Sundance ceremony reenacted the sun's journey across the sky, while the annual ghost dance drew power from the belief that celestial alignment could restore balance to a wounded world. Even their star maps painted on hides depicted constellations as spiritual beings, the trickster Iktomi as the Crab Nebula, or the buffalo Tatanka as the Great Bear. This wasn't mythology as metaphor, it was a lived reality where every meteor shower, eclipse, or comet carried messages for those who knew how to listen. The genius of Native American astronomy lies in its refusal to compartmentalize. Where modern science divides physics from philosophy, these traditions saw the cosmos as a conversation. The Zuni's Shalako ceremony recreated the migration guided by the Pleiades. The Navajo's Hogan doors faced east to greet the sun, while their sand paintings encoded celestial patterns used for healing. The Maya might have had precise calendars, and the Babylonians detailed star logs, but native cultures achieved something equally profound. They wove the sky into the very fabric of daily life, making astronomy not just a study, but a way of being. Their legacy challenges us to see the universe not as distant and detached, but as a living, breathing relative one whose stories are written not just in light, but in the land beneath our feet. Deep in the cliffs of Mali's Bandiagara escarpment, the Dogon people preserved celestial knowledge that still leaves scientists speechless. For centuries, their oral traditions described Sirius not just as a single star, but as part of a triple system including Sirius B, an invisible white dwarf so dense its teaspoon of matter would weigh 5 tons. This cosmic detail wasn't discovered by Western astronomers until the 19th century with advanced telescopes, yet Dogon priests spoke of its 50-year orbital cycle and called it Po-Tolo, meaning smallest seed. How did a culture without optical instruments grasp such sophisticated astrophysics? Some suggest ancient contact with Egyptian or Mesopotamian astronomers, while others point to the Dogon's meticulous multi-generational sky watching. Their cosmology goes deeper. They mapped Jupiter's 4 largest moons and Saturn's rings, embedding this wisdom in intricate sand drawings and mask ceremonies that turned astronomy into living art. Far to the southeast, the stone towers of Great Zimbabwe whisper of another astronomical legacy. The conical structure known as the Tower of the Great Enclosure aligns with the Moon's most extreme northern setting point during the 18.6-year lunar standstill cycle. Its brickwork features chevron patterns that may have served as sightlines for tracking celestial movements, while openings in the walls frame specific stars rising over the surrounding hills. This wasn't just a royal city. It was a stone calendar where rulers derived authority from their ability to predict eclipses and seasonal changes. Similar precision appears in the ruins of Mapungubwe, where gold artifacts depict the cross-shaped Southern Cross constellation, guiding travelers long before European navigators used it as their celestial compass. The Kingdom of Kush, south of ancient Egypt, developed its own stellar traditions under the shadow of pyramids. At the Temple of Ammon in Naka, a relief shows the god Chonsu holding a notched palm branch, a possible tally of lunar months used to track eclipse cycles. Meroitic astronomers recorded celestial events on pottery shards, noting planetary conjunctions that guided the coronation dates of Candace, their warrior queens. Their celestial observations blended Egyptian techniques with distinct Nubian innovations, like using the Nile's flood levels as a natural gauge for calibrating star charts. When the Romans marveled at Kush's unconquered status, they overlooked the celestial wisdom that fortified this empire, where kings timed military campaigns to the appearance of the red star Antares, believing it amplified their strength. From the Berber nomads of the Sahara to the Yoruba sky watchers of Nigeria, Africa's astronomical diversity rivals its ecological variety. The Borana people of Kenya and Ethiopia still use their camel calendar, counting lunar months by the growth of a camel's hump fat, a practical fusion of animal husbandry and celestial observation. The Timbuktu manuscripts reveal 14th-century Malian scholars debating whether Mercury's orbit was elliptical centuries before Kepler's laws. Even today, the Kungsan people of the Kalahari read the changing positions of the Milky Way to predict seasonal rains, proving that some star lore never needed writing to endure. These traditions shatter the myth that advanced astronomy was exclusive to Eurasia. When Dogon elders speak of Namo-amphibious beings who brought knowledge from the stars, or when Shona villagers point to the ruins of Great Zimbabwe as the place where the sun was tied, they're not just telling stories. They're preserving sophisticated systems of knowledge that measured time, navigated continents, and connected earthly life to cosmic rhythms. Africa's skies were never silent. They were alive with meaning, decoded by cultures who saw the universe not as distant and cold, but as intimately woven into every harvest, every birth, every stone laid upon another. Their legacy challenges us to listen more closely to the stars and to the voices history nearly forgot. Look up at the Big Dipper, and you're not just seeing stars, you're glimpsing a story told for millennia. To the ancient Greeks, these 7 points formed the tale of Ursa Major, the great bear hunted eternally by Orion. But cross the Pacific to the Lakota people, and the same stars became a bison's shoulder, guiding hunters across the plains. These celestial narratives did more than entertain. They turned the night sky into a classroom, a moral compass, and a mirror reflecting each culture's deepest values. The Inuit saw the Pleiades as a team of sled dogs, while Aboriginal Australians recognized them as the 7 sisters fleeing the unwanted advances of Orion, represented by the constellation's hunter figure. What's astonishing isn't just the diversity of these tales, but how they preserved practical knowledge. The Maori story of Toma Raretti's Waka, the Milky Way as a celestial canoe, encoded navigational routes, with bright stars marking safe passages through Polynesia's island chains. Some myths served as cosmic almanacs. The Egyptian goddess Nut, arched across the sky with her star-studded body, wasn't just a pretty image. Her swallowing of the sun each evening and rebirth at dawn explained the solar cycle in vivid terms. Similarly, the Chinese legend of the Weaver Girl and Cowherd, separated by the Milky Way except for one Magpie Bridge day each year, mirrored the Vega Altair star alignment that marked the autumn harvest. These weren't fairy tales, they were mnemonic devices, helping farmers and sailors remember celestial timings critical for survival. Even the Babylonian epic of Gilgamesh wove astronomy into its poetry, with the Scorpion men guarding the sun's path through the zodiac, a dramatic personification of the real Scorpius constellation marking the ecliptic. The stars also held up a mirror to human behavior. The Cherokee myth of the Great Leech, a dark constellation in the Milky Way, warned against greed by showing the consequences of draining the world's lifeblood. Norse warriors took courage from Thor's chariot, our Big Dipper, racing nightly across the heavens. These stories taught astronomy alongside ethics, blending celestial mechanics with cultural identity. When the Pawnee performed their morning star ritual, timed to Venus's appearance, they weren't just observing a planet, they were reenacting the cosmic drama of creation, where the first human emerged from a union between the morning star and the evening star. What's truly remarkable is how these myths reveal universal human questions. Cultures separated by oceans and centuries all asked, who put the stars there? Why do they move? Are we alone? The answers varied. The Japanese Amaterasu emerging from a cave to restore sunlight. The Navajo black god carefully placing constellations like a celestial architect, but the wonder was the same. Today, when we point out Orion's belt or Scorpio's tail, we're participating in this ancient tradition, finding meaning in the chaos of stars. The constellations may be arbitrary connections of distant suns, but the stories we've hung upon them. Those are the real magic, the shared human impulse to turn the cosmos into a storybook written in light. At Abu Simbel, the Nile sandstone cliffs cradle one of history's most dramatic celestial performances. Twice a year, on February 22nd and October 22nd, the rising sun pierces 60 meters into the temple's depths, illuminating statues of Ramses Roman II and the gods Amun and Ra-Horakhti. But the fourth figure, Ptah, remains in shadow. He's the god of darkness, deliberately excluded from the light's path. This precision wasn't just architectural vanity. It marked the pharaoh's birthday and coronation, tying his divine authority to solar cycles. Modern engineers discovered that when the temple was relocated in the 1960s to avoid flooding from the Aswan Dam, even a slight misalignment would have shifted this solar event by days, proof of the original builder's astronomical mastery. Half a world away, Cambodia's Angkor Wat mirrors this cosmic choreography. During the spring equinox, the sun rises directly over the temple's central tower, an event so precise it draws thousands of visitors annually. But the real marvel lies in the bas-reliefs. The churning of the ocean of milk scene isn't just mythic art. Its 108 figures mirror the lunar cycle's 108-day intervals between significant positions. Even the temple's 5 towers replicate the 5 visible planets, while its surrounding moat reflects the stars like a still, dark mirror. For the Khmer people, astronomy wasn't confined to priestly scrolls. It was etched into every stone of their sacred city. High in the Andes, Machu Picchu's Intihuatana stone takes celestial interaction even further. This granite protrusion, whose name means hitching post of the sun, casts no shadow at solar noon during the equinoxes. But it's more than a calendar. Inca priests likely used it to predict solstices by observing how sunlight interacted with carved grooves and shadows. Nearby, the Temple of the Three Windows frames the December solstice sunrise, while the Torion Tower's window aligns with the Pleiades rising, crucial for determining planting seasons. The Incas didn't just observe the sky, they wove it into their architecture so tightly that dismantling a single stone could disrupt an entire astronomical calendar. In Persia, the Janta Manta observatories reveal a different approach: colossal scientific instruments built for precision. The Samrat Yantra in Jaipur is a 27-meter-high sundial accurate to 2 seconds, while the Ram Yantra's cylindrical chambers measure a star's altitude and azimuth simultaneously. These weren't just tools, they were open-air classrooms where scholars tracked Mercury's elusive movements or calculated eclipse times without lenses or telescopes. The Hindu and Islamic astronomers who worked here saw no conflict between devotion and discovery, their prayers timed to celestial events, their equations infused with reverence. What unites these sites across continents is their refusal to separate the sacred from the scientific. When Mayan priests in El Caracol tracked Venus from their spiral tower, they weren't just calculating its orbit, they were communing with Kukulkan. The Navajo Hogan's east-facing door welcomes both the morning sun and spiritual renewal. These ancient architects understood something we often forget: that wonder is the birthplace of inquiry, and that the stars inspire not just calculations but poetry etched in stone. Their legacy challenges our modern divisions, reminding us that the first astronomers were also the first poets, reading the sky not just with numbers but with their whole selves. When the sun vanished without warning, ancient civilizations didn't just see darkness, they witnessed the unraveling of cosmic order. In China, astronomers banged drums and shot arrows skyward during solar eclipses, believing a celestial dragon was devouring the sun. Court records from over 3,000 years ago describe these events with chilling precision. The sun was eaten, it was terrible. But what began as terror slowly transformed into understanding. By 600 BC, Chinese stargazers had decoded the Saros cycle, the 18-year pattern of eclipses, allowing them to predict these events with startling accuracy. One legendary astronomer, Hsi and Ho, supposedly lost their heads for failing to foresee an eclipse, though modern scholars suspect their failure was political sabotage rather than scientific error. Babylonian clay tablets tell a different but equally gripping story. Their astronomers, called Tupshar Enuma Anu Enlil, served as celestial spies for kings, interpreting eclipses as coded messages from the gods. A lunar eclipse might warn of an enemy king's death. A solar event could signal doom for the ruler himself. To avoid panic, monarchs installed temporary substitute kings during predicted eclipses, poor souls who'd bear any divine wrath while the real ruler hid safely underground. The brilliance of these ancient scientists shines through their meticulous records. Tablet after tablet logged eclipse dates and durations with such precision that modern astronomers still use them to study changes in Earth rotation over millennia. Halfway across the world, the Maya developed their own eclipse mythology. Their Dresden Codex contains pages of eerie red and black numbers, a danger table predicting when the sun or moon might disappear. They saw eclipses as celestial battles between the sun god Kinish Ahau and cosmic jaguars that sought to extinguish his light. Pregnant women were confined indoors during these events, lest their unborn children inherit the jaguar's savage nature. Yet beneath the mythology lay sophisticated math. Maya astronomers recognized that eclipses only occurred during specific lunar phases, and their long-count calendar could project these events centuries into the future with near-modern accuracy. The Greeks took a more analytical approach. Thales of Miletus reportedly stunned warring armies by predicting a solar eclipse in 585 BCE, though historians debate whether he actually calculated it or borrowed knowledge from Egyptian or Babylonian sources. Later, Hipparchus used eclipse observations to estimate the moon's distance from Earth, coming within 15% of the actual figure, a remarkable feat for the 2nd century BC. These ancient astronomers weren't just stargazers, they were cosmic detectives piecing together clues from the darkness. What unites these cultures is how eclipses blurred the line between science and the sacred. The same event that inspired blood-curdling myths also drove humanity's first breakthroughs in celestial mechanics. When totality plunged the world into unnatural twilight, it didn't just frighten our ancestors, it ignited their curiosity. That duality still echoes today when modern crowds gasp at the sun's corona while scientists measure Einstein's theory of relativity. The sky's greatest vanishing act taught us that even the most terrifying phenomena obey rules, waiting to be decoded by those brave enough to stare into the darkness. The story of the zodiac begins not in glossy magazines, but in the dust of Babylonian clay tablets over 2,500 years ago. Ancient astronomers tracking Jupiter's slow march across the night sky divided its path into 12 equal slices, each named for the constellation it passed through, a celestial yardstick that became the foundation of the zodiac we know today. But these early stargazers weren't plotting horoscopes for love or luck. They were creating a sophisticated mathematical tool to predict planetary motions and divine the god's will. The path of the moon they meticulously recorded was less about personality traits and more about anticipating floods, harvests, and political upheavals. A single cuneiform tablet might log Jupiter's position alongside warnings of potential rebellions or market fluctuations, blending astronomy with statecraft in ways that shaped empires. When this knowledge reached the Greeks, it transformed. Hellenistic scholars like Ptolemy took the Babylonian zodiac and infused it with their own myths, turning cold calculations into a tapestry of archetypes. Aries became the golden ram of Jason's quest, Leo the Nemean lion slain by Hercules. Yet even as astrology gained poetic flair, its roots in precise observation remain. Ptolemy's Tetrabiblos, while detailing how stars influenced human affairs, also insisted on rigorous planetary tracking, a reminder that the line between science and mysticism was once paper-thin. The same scholars debating zodiacal influences were also calculating Earth's circumference or mapping the stars' distances. Meanwhile, across the globe, other cultures were crafting their own celestial maps. The Chinese zodiac's 12 animals, rat, ox, tiger, aligned not with constellations but Jupiter's 12-year orbit, each creature embodying philosophical virtues like diligence or cunning. In Mesoamerica, the Maya interwove their 20-day sacred calendar with zodiac-like symbols, where the howler monkey god governed creativity and the jaguar represented nocturnal wisdom. These systems shared a common thread, the human urge to find patterns in the chaos of the cosmos, whether for farming, governing, or understanding one's place in the universe. The modern zodiac, reduced to newspaper horoscopes and social media memes, might seem a far cry from its origins, but hidden beneath today's sun sign cliches are echoes of ancient genius. Your rising sign traces back to Babylonian ascendant calculations. The concept of planetary houses stems from medieval Arab astronomers who refined Greek techniques. Even the much-mocked Mercury retrograde warnings have roots in real astronomical phenomena that disrupted ancient navigators and scribes. The zodiac's journey from temple walls to TikTok reveals a deeper truth. Humanity has always looked to the stars not just for answers, but for stories that make the infinite cosmos feel like home. What's lost in translation over millennia is the original awe behind these symbols. When a Babylonian priest tracked Venus through Taurus, he saw a god's footsteps. When a Mayan astronomer noted the Pleiades' position, he marked the time to burn fields for planting. The stars were never passive backdrops. They were active characters in the drama of survival. So next time you read your horoscope, remember, you're holding a fragment of humanity's oldest science, a bridge between the observatories of Nineveh and the glow of your phone screen, whispering that the sky still has stories to tell. Buried beneath the Mediterranean waves for 2,000 years, the Antikythera Mechanism emerged from a shipwreck in 1901 as a corroded lump of bronze until X-rays revealed its secrets. This intricate clockwork device, no larger than a shoebox, contained over 30 interlocking gears that modeled the moon's elliptical orbit, predicted solar eclipses, and even tracked the 4-year cycle of the Olympic Games. Its differential gearing, previously thought invented in the 16th century, allowed it to account for the moon's irregular speed as it moves closer and farther from Earth. To grasp its sophistication, picture a Swiss watchmaker's precision combined with an astronomer's vision, all crafted centuries before the fall of Rome. Yet the Antikythera wasn't an isolated marvel. Cicero wrote of a similar device built by Archimedes that replicated planetary motions, while Byzantine texts mention celestial spheres demonstrating the cosmos. These inventions suggest a hidden tradition of mechanical astronomy lost during Europe's medieval period. The Greeks may have even created portable planetariums, bronze orreries carried by wealthy patrons to showcase their philosophical sophistication. What's chilling is how much knowledge vanished when the Library of Alexandria burned, leaving us to wonder how many other Antikytheras were reduced to ashes. Meanwhile, across the ancient world, other technologies bridged the gap between sky and earth. The astrolabe, perfected by Islamic scholars like al-Biruni in the 10th century, could calculate prayer times, measure mountain heights, and even determine the Qibla direction to Mecca, all by aligning its rotating plates with the stars. Persian astronomers engineered quadrants with minute markings accurate to fractions of a degree, while Chinese sky watchers developed armillary spheres with rings representing celestial coordinates, their craftsmanship so refined they detected subtle shifts in planetary orbits. Even humble tools carried celestial intelligence. The Roman portable sundial, small enough to fit in a traveler's pouch, adjusted for latitude with sliding components. The Egyptian Merkit, a simple plumb line and sighting tool, aligned pyramids with true north using the circumpolar stars, achieving precision modern surveyors struggle to replicate. These weren't just instruments, they were extensions of the human mind, turning abstract cosmic patterns into tangible, usable knowledge. The real lesson of these devices isn't just their ingenuity, it's what they reveal about ancient thinking. When a Greek engineer carved minuscule teeth onto the Antikythera's gears, or when an Arab scholar engraved star positions onto an astrolabe's rete, they weren't merely building tools. They were asserting a radical idea that the universe operates by rules humans can decode, replicate, and even mechanize. That leap from observation to simulation marks the birth of computational science. Every time you check your smartphone's astronomy app, you're tapping into a lineage that stretches back to those bronze gears resting on the ocean floor, a reminder that the past was far more advanced than we often assume. History books often shine their light on figures like Ptolemy and Copernicus, but flickering in the margins are the untold stories of women who shaped our understanding of the cosmos. Take Hypatia of Alexandria, the famed 4th century scholar whose lectures on planetary motion drew students from across the Mediterranean. She didn't just teach astronomy, she refined the astrolabe, authored critical commentaries on Ptolemy's work, and likely co-edited the mathematical texts that preserved Greek astronomical knowledge. Yet her legacy was nearly erased when a mob, inflamed by political and religious tensions, dragged her through the streets, a brutal silencing that foreshadowed centuries of women's contributions being written out of scientific history. Centuries earlier and thousands of miles away, the Babylonian priestess Enheduanna was weaving celestial knowledge into sacred poetry. As high priestess of the moon god Nana in Ur, she composed hymns describing Venus as a great flaming boat crossing the heavens, some of the earliest recorded celestial observations attributed to a named woman. Her position wasn't ceremonial. Temple priestesses like her were the data analysts of their day, tracking lunar cycles to set religious calendars and interpreting eclipses as divine messages. The fact that her writings survived on clay tablets for over 4,000 years suggests her influence rivaled that of any royal astronomer. In China's Tang dynasty, a quiet revolution was unfolding in the imperial observatory. Though official records rarely named them, female court astronomers known as Nuguan calculated eclipse times and planetary positions using armillary spheres. Some even rose to supervise the calendar reforms that dictated agricultural and ceremonial life. A 9th century mural in the Dunhuang caves depicts a woman in scholarly robes holding astronomical instruments, a rare visual testament to their presence in elite scientific circles. These women navigated a system that often credited their work to male superiors, yet their calculations guided emperors' decisions and shaped one of history's most precise calendrical systems. The absence of their stories in mainstream narratives isn't accidental. It reflects the systematic erasure of women's intellectual labor. When German nun Hildegard of Bingen wrote about the living light of the stars in the 12th century, her work was dismissed as mystical visions rather than recognized as observational astronomy. The same pattern repeated with Maria Kunitz, whose 17th century book, Urania Propitia, simplified Kepler's complex planetary laws into accessible tables, only to have male contemporaries claim she merely copied her husband's notes. Even Caroline Herschel, who discovered 8 comets and catalogued thousands of stars, was long remembered only as her brother William's assistant, rather than the groundbreaking astronomer she was. Yet fragments of their legacy persist in unexpected places. The names of lunar craters honor early female astronomers like Hypatia and Enheduanna. A 13th century Persian manuscript depicts a woman teaching geometry to male students, hinting at forgotten scholarly traditions. And in the oral histories of indigenous cultures worldwide, from the star-reading women of Polynesia to the Navajo first woman who placed the constellations, we find echoes of alternative astronomical traditions where gender roles were fluid. These fragments form a constellation of their own, mapping a hidden history where women didn't just observe the stars, but helped humanity comprehend its place among them. The challenge isn't just recovering these stories, it's recognizing how their erasure distorted our perception of who gets to unlock the universe's secrets. When the moon bled red over Mesopotamia, Assyrian kings didn't see an omen, they saw an opportunity. Their royal astronomers, trained in the precise art of eclipse prediction, would whisper in the ruler's ear, "The gods have darkened the sun as a sign of your enemy's impending doom." This wasn't just superstition, it was statecraft written in starlight. Across ancient empires, celestial events became political theater, with kings and emperors staging their reigns as cosmic dramas. In Egypt, pharaohs claimed direct lineage from the sun god Ra. Their coronations timed to solstices when the Nile's floodwaters mirrored the Milky Way's sprawl. The message was clear: rebellion wasn't just treason, it was disrupting divine order. The Maya elevated this celestial politics to an art form. Their Star Wars weren't mere battles but meticulously timed campaigns launched when Venus, the warrior planet, reached its greatest brilliance. Glyphs at sites like to call record kings, postponing attacks for years until the heavens aligned, then boasting of victories as if the stars themselves had fought alongside them. A ruler might delay his coronation for a decade until Jupiter's position signaled favor, proving his patience was as strategic as his sword. Their astronomical codices weren't just scientific manuals, they were playbooks for maintaining power through celestial choreography. In China, the mandate of heaven turned astronomy into a legitimacy meter. Emperors employed entire bureaus of astronomers not just to track stars, but to spin their movements. A comet might be reinterpreted as a broom star sweeping away corruption. If the ruler needed to purge rivals, the same event could doom a dynasty if framed as heavenly disapproval. When the supernova of 1054 blazed for weeks, Song dynasty officials quickly declared it evidence of imperial virtue, while later Mongols used records of that same guest star to justify overthrowing them. Controlling the narrative of the skies meant controlling history itself. The political genius of these systems lay in their flexibility. Babylonian kings facing revolt could point to Mars' retrograde motion as proof the gods demanded loyalty. Aztec priests used Venus cycles to schedule sacrificial ceremonies, binding terror and awe to celestial mathematics. Even Stonehenge's solstice alignments may have served as Neolithic propaganda, demonstrating elite access to cosmic secrets. The common thread, astronomical knowledge, wasn't just power, it was the ultimate legitimacy, written in a language everyone could see but few could fully decipher. What's often overlooked is how this shaped scientific progress. When a Mayan astronomer refined Venus tables or a Chinese bureaucrat corrected the calendar, they weren't just pursuing truth, they were jockeying for favor in cutthroat courts. The very precision we admire in ancient star records was born from rulers' need to outpredict rivals, to prove their gods were stronger, their scholars sharper. In an age without satellites or telescopes, the ability to say, "the sun will vanish on this day," and be right was more valuable than gold. It's no accident that many early astronomers held titles like Royal Sky Watcher or Celestial Secretary. Their work didn't just map the heavens. It held kingdoms together. The night sky wasn't just a scattering of stars to ancient cultures. It was a sprawling menagerie, alive with creatures both real and mythical. In Egypt, the falcon soared across the heavens as Horus, his right eye the sun and his left the moon, a divine embodiment of kingship and celestial balance. But this wasn't mere whimsy. The falcon's keen vision mirrored the sun's unblinking gaze, and its hunting prowess symbolized the pharaoh's authority over chaos. Similarly, the scarab beetle, rolling the sun disk like dung across the sky, captured the Egyptians' awe at daily solar rebirth, an insect's humble labor elevated to cosmic significance. Half a world away, the Chinese azure dragon coiled through the heavens, its celestial body marking the spring equinox and its movements dictating the agricultural calendar. This wasn't just a decorative myth. The dragon's association with rain and rivers tied directly to monsoon predictions, while its celestial rivals, the white tiger, vermilion bird, and black tortoise, anchored the seasons in a celestial dance of elemental forces. Even the Dogon's cosmic crocodile, said to carry the weight of the world on its back, encoded practical knowledge. Its association with Sirius B's orbit may have symbolized the star's gravitational pull, a concept Western science wouldn't grasp for millennia. The Greeks, too, populated the sky with beasts both noble and monstrous. Leo the lion wasn't just a random grouping of stars. It commemorated the Nemean lion slain by Hercules, its brightest star Regulus marking the heart of the celestial king. Nearby, Scorpius eternally chased Orion across the heavens, a warning against hubris written in starlight. These constellations weren't bedtime stories. They were mnemonic devices, helping sailors navigate by claw and tail, or farmers track the seasons by the bear's turning paw. What's fascinating is how these animal astronomers reveal ancient ecological intimacy. The Inuit saw Ursa Major not as a bear but as a caribou, its antlers tracing the arc of the northern sky. Aboriginal Australians spotted emus in the dark patches of the Milky Way, their celestial outlines mirroring seasonal ground paintings. Even the Maya visualized the Milky Way as a cosmic serpent, its undulating form echoing the sinuous rivers of their jungle home. These weren't abstract metaphors, they were survival maps, blending celestial patterns with knowledge of migration routes, breeding cycles, and food sources. Today, we've replaced these vibrant bestiaries with sterile star charts and GPS coordinates, but the legacy lingers. The zodiac's menagerie, from Taurus the bull to Pisces the fish, still guides millions, while spacecraft bear names like Orion and Dragon. Perhaps there's wisdom in this ancient practice of seeing ourselves reflected in the stars, not as masters of the cosmos, but as part of its grand, interconnected web, where a falcon's wings still carry the sun, and a crocodile's back still bears the weight of worlds. Standing at Stonehenge during the summer solstice, you'd witness a phenomenon our ancestors planned millennia ago. The sunrise perfectly aligned between massive stones, marking the longest day of the year. This wasn't just a spectacle, it was a prehistoric calendar carved in rock, a way to track time by the sun's journey. The Maya took this further, crafting a 365-day solar calendar so precise it rivaled modern systems, with corrections for leap years encoded in their temple carvings. Their Hob calendar synchronized with agricultural cycles, while their sacred Tzolk'in wove a 260-day spiritual rhythm, creating a celestial tapestry of time that governed everything from planting to prophecy. The Babylonians, though, gave time its modern texture, dividing the day into 24 hours, each hour into 60 minutes. They built their system on the base 60 mathematics inherited from Sumerian scribes. Why 60? Because it's divisible by so many numbers, a practical choice for traders and astronomers alike. Their lunar calendar required constant adjustment, leading to the occasional leap month to realign with the seasons, a problem the Egyptians tackled differently. Their 365-day solar year, while elegant, drifted by a quarter day annually, so over centuries the flooding of the Nile, their agricultural lifeline began arriving in the wrong season. Enter Julius Caesar, who, advised by Alexandrian astronomer Sosigenes, overhauled Rome's chaotic calendar with the Julian system in 45 BC. Adding leap years every 4 years fixed Egypt's drift, though it overcorrected slightly, an error that would snowball into 10 misplaced days by the 16th century. Pope Gregory Roman XIII reform in 1582 fine-tuned it further, dropping leap years in century years not divisible by 400, giving us the Gregorian calendar we use today. But even now, traces of ancient timekeeping linger. The 7-day week, that's Babylonian astrology, each day tied to a celestial body: sun day, moon day, Saturn day. What's striking isn't just the accuracy of these systems, but their universality. The Chinese combined lunar and solar cycles into a lunisolar calendar, while the Inca used towers near Cusco to mark solstices with sunlight pillars. Beneath the practicality lay deeper truths. Calendars weren't just tools, they were bridges between earth and sky, ways to tame the chaos of time into rhythms that made life predictable. When a Babylonian priest tracked the moon's phases or a Mayan scribe calculated Venus's return, they weren't just counting days, they were weaving human stories into the fabric of the cosmos. Our modern clocks and planners, for all their precision, still echo that ancient urge to sync our lives with something greater, to find order in the stars' endless dance. Archaeoastronomy turns ancient stones into celestial timekeepers, revealing how cultures worldwide wove the cosmos into their architecture. Take Newgrange in Ireland, a 5,000-year-old tomb where winter solstice sunlight pierces a narrow passage to illuminate the inner chamber for precisely 17 minutes. This isn't random chance, it's deliberate engineering, a Neolithic alarm clock marking the year's rebirth. Similar precision shines at Chichen Itza's El Castillo Pyramid, where the equinox sun casts a serpentine shadow slithering down the steps, merging astronomy with sacred theater. These structures weren't just aligned with the sky, they conversed with it, turning celestial events into public spectacles that reinforced cultural identity and spiritual power. Yet interpreting these alignments isn't always straightforward. The Orion correlation theory, proposed in the 1990s, ignited fierce debate by suggesting the Giza pyramids mirror Orion's belt star pattern. While the alignment is visually striking, critics point out the star's positions shift over millennia due to precession, meaning the match would only have been perfect around 10,500 BC, far earlier than mainstream archaeology dates the pyramids. This tension between celestial patterns and archaeological evidence lies at the heart of archaeoastronomy's challenges. Are we seeing intentional design or imposing modern fantasies onto the past? The answer often lies in statistical analysis. At Scotland's Callanish Stones, researchers used 3D modeling to prove the monolith's frame lunar standstill events with a 95% probability of intentionality, blending hard data with cultural context. The field's real power lies in its interdisciplinary lens. In Peru's Chanquillo complex, 13 towers form an artificial horizon, marking the sun's yearly journey with uncanny accuracy. But archaeoastronomers didn't stop at measuring angles. They studied Inca chronicles describing solar worship and examined pottery shards depicting ritual gatherings at solstices. This triad of architecture, text, and artifact transforms a row of ruins into a living observatory where politics, religion, and science converge. Similarly, Cambodia's Angkor Wat reveals its genius when studied through multiple frames. Its westward orientation breaks Hindu tradition but perfectly aligns with the spring equinox sunrise, suggesting a fusion of cosmological symbolism and imperial propaganda. Controversies persist, and that's where the discipline thrives. The Nebra sky disk, a 3,600-year-old bronze artifact from Germany, was initially dismissed as a hoax until archaeoastronomers decoded its gold arcs as solstice markers and Pleiades star cluster. Even Stonehenge's purpose evolves with new technologies. Recent LiDAR scans show its surrounding landscape is riddled with aligned burial mounds and processional routes, expanding its role from solitary calendar to centerpiece of a ritual cosmos. These discoveries remind us that ancient sky watchers didn't separate observation from meaning. A shadow touching a stone wasn't just a date, it was a dialogue with the divine, a moment when heaven and earth touched. Archaeoastronomy's greatest lesson isn't about precision, it's about perspective. When a Navajo elder explains how the three-star belt of Orion represents the holy people who brought farming to their ancestors, or when a Polynesian navigator describes reading ocean swells as star paths reflected in water, they're offering something textbooks can't, a worldview where science and story orbit each other. This field doesn't just decode the past, it challenges us to see the sky as our ancestors did, not as distant points of light, but as a living map, a clock, and a compass all at once. The stones whisper and the stars reply. The notion that ancient civilizations needed extraterrestrial intervention to master astronomy doesn't just undermine human achievement, it erases the painstaking centuries of observation, experimentation, and cultural innovation that shaped our understanding of the cosmos. Take the famous case of the Dogon people of Mali, whose detailed knowledge of Sirius B, a white dwarf invisible to the naked eye, has been cited as proof of alien contact. But dig deeper, and a simpler explanation emerges: cultural exchange. French anthropologists visited the Dogon in the 1930s, coincidentally during a time when Sirius B's existence was widely discussed in European astronomy circles. The Dogon's own oral histories suggest their astronomical traditions evolved through trade with neighboring Islamic scholars, who had access to Hellenistic and Babylonian star lore. Rather than a cosmic handout, their knowledge reflects humanity's interconnected genius, a web of shared discovery stretching across continents and generations. Pseudo-archaeology's greatest flaw isn't just its reliance on fantastical explanations, it's the way it strips ancient cultures of their agency. When theorists claim the pyramids or Stonehenge must have been built with alien technology, they ignore the archaeological receipts, quarry marks at Giza showing how blocks were cut, or Neolithic tool kits found near Britain's stone circles. The Maya's Venus tables weren't handed down by star visitors. They were refined over generations of priest astronomers tracking the planet's cycles with knotted cords and observatory sightlines. These cultures left behind detailed records of their methods, from Babylonian clay tablets documenting eclipse patterns to Incan quipu strings encoding calendrical data. Dismissing these as primitive attempts to explain alien gifts isn't just inaccurate, it's disrespectful to the intellectual labor that laid astronomy's foundations. The allure of these theories often stems from a misunderstanding of ancient technology. The Antikythera Mechanism, for instance, seems impossibly advanced for its time until you examine Hellenistic metallurgy and realize its gears were crafted using techniques also employed in contemporary olive presses. Similarly, claims that Nazca lines in Peru required aerial guidance fall apart when you consider the simple tools and surveying methods available to their creators. Ancient engineers didn't need alien blueprints, they had ingenuity, patience, and generations of trial and error. The real mystery isn't how they achieved these feats, but why we're so quick to doubt their capability. At its core, the ancient astronaut narrative reflects a modern bias, the assumption that progress must follow a linear, Western-centric path. When the Polynesians navigated thousands of miles using star compasses, or when Aboriginal Australians memorized star maps spanning 65,000 years, they weren't relying on extraterrestrial GPS. They were developing sophisticated, localized sciences that prioritized different kinds of knowledge. Reducing their achievements to mysteries ignores the diversity of human innovation. The truth is far more inspiring. Across 6 continents, cultures independently decoded the cosmos using the tools they had, from Babylonian arithmetic to Polynesian wave lore. Debunking these myths isn't about dismissing wonder, it's about redirecting it. The story of ancient astronomy isn't one of passive humans waiting for alien saviors, but of curious, resourceful people transforming the night sky into a tool for survival, spirituality, and societal growth. When we credit their accomplishments to extraterrestrials, we rob them of their rightful place as pioneers. The next time you hear someone claim the ancients couldn't have done it alone, remember the Mayan scribe calculating Venus's orbit by candlelight, or the Egyptian architect aligning a pyramid to within a fraction of a degree using nothing but shadows and stars. Their legacy isn't a puzzle to be explained away. It's a testament to what humans can achieve when we look up and dare to understand. Kepler didn't just stumble upon his laws of planetary motion. He pored over Ptolemy's ancient star charts, recognizing patterns scribed onto parchment centuries earlier. Those same geometric models, refined by Arab astronomers like al-Battani, became the scaffolding for his revolutionary insight that planets move in ellipses, not perfect circles. Fast forward to the Apollo missions, where engineers relied on Babylonian lunar cycle records to calculate trajectories, proving that even our greatest leaps into space are tethered to observations first made under torchlight on clay tablets. This isn't just continuity, it's a conversation across time, where each generation whispers its findings to the next. NAS, a jet propulsion laboratory, still references the Dresden Codex, a Mayan manuscript predicting solar eclipses within hours over 1,000 years ago. Modern astrophysicists cross-check these records against satellite data to study Earth's rotational slowdown, leveraging indigenous knowledge to solve contemporary puzzles. The Hubble telescope's breathtaking images of distant nebulae, they answer questions first posed by the Greeks pondering the Milky Way's hazy band, and by Polynesian navigators who saw it as a celestial canoe path. Ancient star catalogues like Hipparchus's painstakingly compiled list of stellar positions now help astronomers track proper motion, the slow drift of stars over millennia, proving that even fixed constellations are in motion, just as Babylonian sky watchers suspected. The threads connecting past and present aren't just poetic, they're practical. When the Chandra X-ray Observatory detects a supernova remnant, Chinese court records from 1054 often confirm the event, providing timelines no computer simulation could replicate. Archaeologists excavating Nineveh found clay tablets documenting Jupiter's retrograde motion, the very phenomenon that clued Kepler into orbital mechanics. Even Stonehenge's solstice alignments find echoes in modern heliophysics, where understanding solar cycles hinges on recognizing long-term patterns first noted by Neolithic astronomers. What unites these moments isn't just shared curiosity, but shared methodology. The scientific method observe, hypothesize, test was alive in Ptolemy's Alexandria as he refined his epicycle models, and in 12th century Maragha, where Nasir al-Din al-Tusi designed instruments to challenge Ptolemy's errors. That same spirit drives the James Webb Space Telescope today, probing cosmic mysteries first glimpsed by Inca priests tracking the Pleiades' heliacal rise. The tools have changed, but the hunger to understand remains. This legacy humbles and inspires. Every time an astronomer calibrates a spectrograph or a rover beams back images from Mars, they're part of an unbroken lineage, one that began when the first human looked up and wondered why the stars move, how far they are, and what they're made of. Our satellites and supercomputers don't replace those early stargazers. They fulfill their wildest dreams. The night sky that guided Polynesians to new islands and Babylonians to predict eclipses still beckons, reminding us that science isn't a solitary sprint, but a relay race spanning civilizations. The baton passes, but the questions and the wonder remain the same. Step outside tonight, and you're standing in the same classroom as Babylonian priests and Polynesian navigators. No telescope required. Start simple. Track the moon's phases with nothing but your eyes and a notebook. Ancient cultures from the Maya to the Chinese timed their lives by its waxing and waning, noting how its position shifted a hand's width each night. Try sketching its shape daily for a month. You'll begin to see what they saw, a celestial clockwork ticking overhead. On the third evening after the new moon, when that slender crescent appears, you're witnessing the same young moon that told farmers in Mesopotamia to plant barley and signaled the start of months in Hebrew calendars. For a deeper challenge, learn to navigate like the Polynesians. Find the Southern Cross or North Star, then notice how their height above the horizon changes as you walk. This is how wayfinders judged latitude without instruments. Next, watch for steering stars, bright points that rise and set in consistent spots. The Hawaiian star compass divided the horizon into 32 houses, each anchored by a celestial marker. Stand facing east at dawn, and you're aligning yourself with Hoculaire Arcturus, the same star that guided voyagers to Tahiti. Modern apps like Starwalk can overlay these ancient constellations, revealing how the Greeks' Orion became the Lakota's Hand constellation, its belt stars marking a warrior's outstretched fingers. Build a sundial from a stick and stones. Egyptians called these shadow clocks, using them to divide daylight into 10 parts plus 2 twilight hours. Place it in a sunny spot and mark where the shadow falls at each hour. You'll quickly notice the curve shifts with the seasons, just as the builders of Stonehenge tracked solar movements. For solstice magic, find a window or doorway where the rising sun strikes only on the longest or shortest day, recreating the precision of Machu Picchu's Intihuatana stone. Even cloud watching holds ancient wisdom. Polynesians read subtle shifts in color and texture to detect distant islands, while Inuit used sundogs, halos around the sun, to predict weather. The real power of these practices isn't just in replicating the past, it's in rediscovering the sky as a living, interactive map. When you spot Venus blazing at dusk, you're seeing the same evening star that told Mayan priests to prepare for sacred ceremonies. Count the Pleiades' visible stars. If you see 6 instead of 7, you're participating in a test of eyesight documented in Greek and Aboriginal traditions. Every time you note a constellation's seasonal return, you're joining an unbroken chain of observers stretching back to Lascaux's cave painters. The tools have changed, but the wonder hasn't. Tonight's sky is still the same boundless scroll where humanity first wrote its stories, and with a little patience, you can learn to read them again. From the pyramids to Polynesian canoes, ancient astronomy was never just about charting stars. It was humanity's first grand collaboration with the universe itself. These civilizations, though separated by oceans and millennia, were united by something profound: the realization that the sky wasn't a distant spectacle, but a living, breathing part of daily existence. The Egyptians didn't merely align temples to the sun, they wove time itself into stone, turning solstices into dialogues with the divine. The Polynesians didn't just navigate by stars, they memorized the ocean's pulse, hearing celestial rhythms in the crash of waves against their hulls. And the Maya, they transformed Venus's dance into a sacred calendar, proving that astronomy could be both precise calculation and poetic ritual. What's extraordinary isn't just their accuracy, it's their creativity. The same Babylonians who calculated Jupiter's path with geometric precision also saw omens in its retrograde motion. The Dogon, who mapped Sirius's invisible companion, embedded that knowledge in masks and dances, turning astrophysics into art. This duality, myth and math, observation and storytelling, reveals a truth modern science sometimes forgets. That wonder is the engine of discovery. The ancients didn't compartmentalize. A sundial could be a farmer's tool, a priest's sacred instrument, and a king's claim to cosmic authority all at once. Their legacy isn't confined to relics or ruins. It lives in the way we still mark time by their calendars, navigate by constellations they named, and marvel at eclipses they predicted millennia ago. When the Hubble telescope captures a nebula's glow, or the James Webb peers into the infancy of galaxies, we're fulfilling a quest they began not with silicon chips, but with bone tools and charcoal sketches. The tools have changed, but the questions endure. Where did we come from? What's out there? Are we alone? Tonight, when you step outside and gaze upward, you're not just an observer, you're part of an unbroken chain. The stars that guided Phoenician traders to new shores still shine for you. The moon that told Mesopotamian farmers when to plant still waxes and wanes on its ancient schedule. And that itch of curiosity you feel, that's the same spark that compelled a Neolithic hunter to paint the Pleiades on a cave wall, or a Babylonian scribe to track Venus's path across a clay tablet. The cosmos hasn't changed, but our understanding of it has, layer by layer, century by century, built on the foundations they laid. So look up, not just with your eyes, but with their perspective. See the sky as they did, not as a void to be conquered, but as a story to be read, a puzzle to be solved, and above all, a home to be known. The universe is vaster than they ever imagined, yet somehow they grasped its essence, that we belong to it and it to us. And in that shared belonging across time and space, we find astronomy's oldest and most enduring truth, that the night sky isn't just above us, it's